Okay, let's go and get started. Hope everyone feels a little bit better now that they didn't have a late class the night before. But today, we'll go over our previous quiz, which basically was over, over statics and a little bit about object-oriented design. And then we're going to do a little bit more into design, because that's actually most of the class is talking about how you organize objects. But we're also going to start jumping into array lists and arrays, which are very important for basically keeping track of different things. So we'll go into that, and then we'll talk about your lab. I've noticed, please pay attention to the lab, because I've noticed this lab is where there's kind of a jump for a lot of students. A lot of students will have difficulty, especially with part 3 of this lab. So make sure you understand what needs to happen before you leave today, so you can at least think about it and work over the weekend. Okay. So let's talk about, talk about the quiz. What are these type of class relationships? What's a dependency? Getting the terms. So many terms. I know there's a lot of terms. But it says uses. So the class uses another one. What does that mean?
Does it borrow attributes from the other one?
Borrow attributes?
Uses attributes?
In a way, not. I know where you're trying to go, but not quite. It doesn't use the attributes of the class. It's more like it uses the class itself. So the other class is required for this class to exist. For example, when one class relies on the functionality of another. Oh, there, that's perfect. So right here, a string class has a dependency on itself, which is actually completely legitimate. You have two strings, and in order to call the concatenation function, it needs to be passed a string. So it uses a string in order to fulfill its functionality. A better example with our code that we talked about last time. You have a house. House uses a room. So in order for the house class to exist, you need to have a room class or a room object. So that's a dependency. House depends on rooms.
So does room depend on house?
But room does not depend on house in this regard. You jump over here to room. There is no dependency on a house. It is completely independent of the house in this regard. So the dependency is one way here.
Okay.
While with the string, it was, I guess, kind of circular. But that's fine. All right. Let's see. An aggregation has a. Ooh, this is kind of the same thing. So, when one is composed of one or more objects. So, the dependency with the house is also a aggregation or has a dependency. Let me try and explain the difference. So, house has a room inside of it. So, it's not only is it dependent on room to exist because you have to use it in order to create a house with the constructor, it also has a room. So those are two separate types of dependencies. We could have written this function. Notice this function, we didn't have to store rooms. We could have just ignored it. Then there would just been a dependency because for this function to exist, it would depend on rooms being able to exist. So the aggregation is another layer here where it has to actually have a room. The string object doesn't have an aggregation of itself. It doesn't have a string inside of itself. It's just the string itself. Welcome, Tyler. How's it going?
Been better.
Been better?
Exhausting.
Exhausting? Got your lab done?
Well, the baby.
The baby just came.
And then I had to stop at the gas station to get gas in my truck, and there was a robbery.
Oh, man.
I had to bust in and save everybody.
Well, you got to protect your baby, too.
Yeah, well, luckily it wasn't that close to the house.
Okay, good.
But it was close enough that I had to do something.
Okay. Well, thank you for helping out your fellow humans.
Keep track of the community. You gotta do my part.
Does that make sense? The difference? This difference can be hard at first to understand. Dependency, it uses it, aka a function requires it. Has a means it's actually part of the class. Another example is a car has a chassis and an engine, so that's right there, the aggregation. How are overloaded methods distinguished from each other? More and more terms.
Well, it's not, I don't want to say it because I'm thinking of like C++. Like,
It's the same thing.
so the parameter list?
Yeah, it's the
Okay.
parameter list. It's the same thing. By the unique signature, which includes number, order, type of parameter. It's really the parameter list. Note that the return is not taken into account. So if you try and write two different functions with the same method name and parameter list, but return two different things, it's not going to work. It really only takes into account the parameter list. What is method decomposition or functional decomposition?
Breaking it down and dividing it into parts to make it easier.
Yeah, dividing into parts to make it easier. Divide and conquer, a very common technique when programming. All right. What does the this reference refer to?
The current one.
The current what?
The current object.
The current object that's executing. So you use it inside your class. First to the current executing object. So public string concat str string.length, this str's length, this.length, the current object's length method. Any questions about this? It's important to understand what this is, even though it's a pronoun.
When did you say you can't use it? You can't use this?
You can always use this.
Well, you were saying like in class you had this house or something like that, but you said like, I don't remember. But it was some way that you couldn't use it.
Maybe in a static method, because there is no executing object.
Yeah.
Okay, yeah. So in the static method, this cannot be used because it doesn't make any sense. What would it point to? Why do we write unit tests? Wow, I got a lot here. Why do we write unit tests? Why do we do tests at all?
Check for errors.
Check for
Make
errors.
sure it works.
Make sure it works. Make sure it works the way it does work. So, first, it actually makes your development faster if you test first. I know it's hard to believe, but from experience, that's the case, sadly. Reduce the cost of a change, because if you make a change, you can test to see if the change is good or bad.
You made new features.
You may need new features. Oh, I love English. Helps you realize when to stop coding and fix issues before they become worse. That's always a good one. People will go down a rabbit hole, and when they come back, it's not even useful. Well, this test will stop you before you go too far. Tests actually act as a documentation of how you want your code to behave. Let's see. Improve your design, can help with understanding better ways to solve problems, constrain the features, show what it will not do. It also helps defend against other programmers, especially if they try and go in and change your class, and then they all of a sudden fail your tests. At least it's a way to tell programmers, hey, it's supposed to be doing this. Reduces fear if things aren't working, and they can be a metric to measure code quality. All right. Here's a really hard question. Can we write a program that'll automatically test someone else's code and prove it's correct?
You already do. You already have one of those. The autograde.
So one person says yes.
I agree with him.
You agree with him?
Yeah.
Anyone? So it cannot be done.
Oh, well, never mind.
And when I say it cannot be done, I'm not saying no one has found a way to do it. I'm saying someone has proven that it is impossible. So we can't write a program to tell you if your program's correct or not. That's why you have to write tests. That's why we write tests. That's the next best thing we can think of. After proving, we can't write a program to prove you're correct.
Is that not what the autograder does? Or just
You just run tests.
But it does check to see if it works.
It checks to see if it works under certain constraints, but it's not an exhaustive list of everything that I could possibly throw at your program. What are stubs and why are they important? What are stubs?
They're just throwing it out there, putting everything down into your program.
Putting everything down your program. Wouldn't that include the code?
It is the code.
It is the code. All right.
Stubs are code.
Stubs are code.
But
The outline?
It's the outline. It's all your class, your function headings, declarations, but not the implementation of your function. That's stubbing it out. And you usually return some default value. Why would we want to do that? So do I do two things? No. Why would we want to do that?
If you're working with someone else, you might want to know what the other person wants to put into the code so it doesn't interact with something else.
Exactly. So if you stub it out, you're giving a design, actually, of what your program does, and then other programmers can see how to interface with your code, even if you haven't implemented it yet. But at least
So
you
how are they not the same as comments?
Okay, here we go. So if we were in house and I did, oh, here we go, here's a stub. Boolean addition string furniture. I'm just telling you, you're going to pass me a string representing the furniture and I would add it. Notice that this function, the implementation, doesn't do anything. It's just a stub. I'm just telling you how you interface with this function through this class
Okay.
by just stubbing it out.
Okay.
A comment, but now you can actually write your code against this and run it. It won't do anything, but you can at least compile and run. A comment, you can't compile and run it against it, yeah, because it's ignored. Great question. Any others? All right. Let's see here. The author says, by avoiding implementation before interface is complete, save stubs, save time and energy. Basically, it helps you do design is really what it comes down to. So hint, hint for your next phase after requirements, I highly recommend you stub it out. And also for your labs, you probably should start by stubbing it out. Open up IntelliJ, stub out the classes with the headings from the API.pdf, and then go from there. Oh yeah, any questions about the quiz?
did I get 100?
Did you get 100?
Always.
So, sure, but just like, whose line is it anyways?
That's good shot.
The points don't matter.
Yeah, thank you.
The points don't matter.
That is a great show.
That is a great
Seen
show.
the bloopers? You have to watch the bloopers.
I've never seen the bloopers.
Oh my god. Like, because a lot of the times they can't say stuff on TV. Like, the director comes in and he's like, whoa, 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 you can't say that. We can't do that. Skit.
Oh.
So everybody's just like, these guys, Like, flipping them off behind their backs, making fun of them.
Mm-hmm. All right, well, you're reading. Go ahead and read Chapter 7. Again, it's pretty short. I do jump back to Chapter 1 in Core Java, read sections 8 and 9 if it's not clear about arrays and array lists. I do jump back and get that done. Okay. Stop.